Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
This podcast episode on Cut the Crop is from the 2023 FAR conference, where Owen Gibson from FAR talks about growing maize in the South Island.
Right, so I took on this project when I sort of came to FAR in 2020. We were first talking about doing this narrow row spacing. So in 2021, we decided how we're going to do this work, and we had a paddock at our Chertsey site where we thought we'd plant it because we had to put something into anyway, so we used a commercial planter to establish these crops. And while we're doing it, we were figuring out how we can do narrow row spacing at South Island with no gear really available. So we just used a commercial planter at 76 centimetres and planted that, and then cut the plots, double drilled them by shifting over onto GPS by 38 centimetres and half the population in those rows to achieve the same population in each plot. So it was a large-scale trial with 4 replicates, and you can see some of our students in here doing spacing uniformity work. They look happy there. A lot of the time they weren't happy. But what did we see? So in the first year, we saw a trend. I like that word sometimes when you don't get what you want. A trend for a yield advantage for the narrow row at the 38 centimetre plots, which was 2 tonnes per hectare. So it's not a small amount, and it was very close to being significant. It's at 90%, it is significant. We had 3 different plant populations that we were testing this on. We were trying to do it at 100,000, 120 and 140,000 plants per hectare. Unfortunately, trying to get that going through the drill, changing on the fly, we struggled to achieve the populations we're after, and that sort of really narrowed our results we were getting from their first years of trials. So in last season, first of all, actually, this is just what the trials looked like. So on the right here is the large-scale plots. That's only 3 plots. There was 24, but you can see they've got the 76 centimetres in the middle and 2 different 38 centimetre plots on the outside. So you might not be able to see that from there, but it was just interesting to see how the architecture of the leaves, of the canopy of the maize changed between the different row spacings. And then if we look on here, this is the small plot trial that we ran in the second year. It looks a bit horrible with lots of missing plants. Our spacing uniformity wasn't very good, but you can see how the plants do change their architecture to take up the available space. So in the last season's trials in 2020 and 2023, we actually had some really nice yield advantages for narrow spacing. This was highly significant going across all the different spacings. So from our 30 centimetres right across, it was the highest in all the populations. What we did see is that the population didn't actually change the yield of the maize at all. So the maize plants were able to increase in size at smaller population densities, and then at the higher population densities, they were reducing individual sizes, but there was enough plants here to overcome that change. But it was nice to see that we had, I think it was a 17% increase of 30 centimetres. That's an average of between all the populations, but from 30 centimetres to 70 centimetre plots. And 6% between 30 and 40, and 8% between the 30 and 50 centimetre row spacing treatments. So one thing to note about this trial, when we're trying to decide how to do this to get more treatments, the row spacing treatments, I'd spied a single row planter in a shed at FAR that I don't think anyone knew existed. So I pulled that out and planted the trial with that. It took all weekend. But we did have problems with their uniformity. So there was, even though the data looks really good, we did have some issues with it. With going forward, we want to try trying to fix up. And the other thing we did when we harvested it, using just a chipper to take our silage cuts, it didn't give us a very good forage sample, and when we're doing our dry matter percentages, they were sort of all over the show. So even though it looks really good, we have got a lot of work to do to prove this concept, and I think that's what we'll be doing next season. So what we're thinking that how this narrow row spacing was really going to help our yield, especially in a cooler grown region in South Island compared to the North Island, or even if it's looking at somewhere in the States where we're doing a lot of this work in the northern part of the Corn Belt, is that by narrowing the row, we're utilising a lot more solar radiation early on in the season. So we can reach canopy closure faster, utilise that solar radiation that's lost to bare ground in the early days. But when we run it, and for the last 2 years, we haven't actually really seen much of a difference in it. We do see a difference in the leaf area interception, leaf area index between the population, but not from the actual row spacing, and that was the same last season as well. By the time, wrong button. By the time we're getting into, we're getting grain fill, we are starting to see it by the populations, but really it's quite a flat line across for the row spacings. If we look to the right on this graph, this is just stole that slide from a Pioneer research booklet. That's why it's not very clear. But that is showing how nice the leaf area index can be a good indicator of our yield potential in our maize crops. We want to be hitting that sort of around 5 to 6 leaf area index to be maximising our yield. So what are we looking at from the narrow row spacing? So I think this is a good slide to just really show how we're increasing the plant's ability to harvest nutrients and also to reduce competition between the row. So in our 70 centimetre row spacing treatment, which we used as our standard proxy for our 76 centimetre spacing, at 90,000 we've only got 18 centimetres between each plant within the row. And if we're getting into really high populations down to 130 plants, 1,000 plants a hectare, that's only 10 centimetres. So that's the very narrow amount of space for that plant to utilise the nutrients there and also allow that canopy to expand and utilise that radiation. So if we go on the right and reduce it to 30 centimetres, you can see here at 110,000 plants a hectare, we've actually produced a square pattern. So that's allowing that plant the maximum amount of space it can for nutrients, light, water, and whatnot. And I think also the benefits of narrow row spacing that we can get is actually allows us the canopy cover, which we mentioned, that's reduces ET, our loss of moisture from the bare soil. It's better for herbicide. We've got canopy closure, we're shading weeds, so a lot of the time we can get away with just a pre-emerge herbicide or just one early post-emerge herbicide. So there's lots of benefits for narrow row maize, I think, anyway. So it's not just the canopy of a crop that's utilising, has been able to utilise the narrow row spacing. So if we look at this work on the left, this comes from the States by Fred Below. People may have heard him last season when he came out. It's looking at the root architecture between the plants. So if you see for every additional 15,000 plants per hectare, there's a 15 to 18% reduction in root growth between the different spacings. So they're using 76 and 50 centimetre row spacings. And I put this on the right, just this, looks like a mutated full armyworm, but just looking at, you can see between 70, 50, 40 and 30 centimetre row spacings, just even if you look down the amount of light that's actually getting through the canopy and hitting the soil between the different spacing treatments. Oop, went far. They're supposed to play. Anyway, So what's next for the project? So first of all, we want to take this for one more year of small plot trial work, try to fix the problem with the uniformity, spacing uniformity, to really fix that up, take that variable out, work on the forage quality of it, which is a massive aspect for our maize, especially, we're selling it as forage, as silage to dairy farms, so that has to be one of the key attributes. And then if we see the same, it finally worked. If we can get those nailed, then we'd like to see taking it to the regions. Can we take it down to Southland? Can we go to Marlborough? Or do we even go up north with this narrow row spacing work? And then ultimately, I'd like to see us take it on farm to have it as large-scale trials with side-by-side comparisons. I think it's so good if we can use farm equipment, commercial equipment for running these tests to actually really test the numbers. It's all good doing small plot trial work, but it's really, once you get it on farm, that's where the results really actually start proving themselves.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.